All right, what you're looking at is an IF can that come out of a radio, and a magnet does not stick to the case, so it's aluminum. And that white stuff, this I love my zoom on it. See that white stuff? That's aluminum oxide. That's also on the bottom of this can. So this is real bad, and I picked this one so you could actually see it. Now, over a period of time, an aluminum can. Now this one is bolted down. The NC57 have darts or arrowheads, and as they go down in the chassis, the arrowhead goes through a hole and then it opens up and locks itself to the chassis. So I finished an NC57, and as I'm peaking up the IF, every time I reach a peak, the whole radio goes in oscillation. So you might think, well, it's in the gain section or all this stuff. So I went looking. I didn't know. You know, you can get problems that you work on different kinds of radios and you never see a radio that's 60 years old or more and the IF can has oxidized. You won't see it. You may never see it. Meanwhile, there's a guy that all he works on are old radios, and he gets this problem. And he says, every time I pick up the IF can, the radio goes in oscillation. Now he knows he's recapped the radio. He's got all the correct voltages. All the resistors have been checked out. And he's got this problem. And somebody else drops by, not the bullshit artist, the genius, and he says, clean the IF can, the bottom and the chassis where it meets. He says, the can itself is acting as an antenna. It's RF insulated from the chassis due to the oxide on the bottom of the can. And you think like, well, how bad could that oxide be? Well, I want to tell you, I found 2 radios with the same problem. And when I know I'm in over my head, I tell you, I go reading. I'm not going to play make-believe. I don't know what I'm doing. I have a problem I never saw before. And the first thing I do is I go looking for an answer. Someone that's fallen in the rabbit hole. And they're willing to post their information. And there it is. Clean the IF can. So when I actually did undo the darts, you got to go underneath the chassis and you squeeze these darts in. And then you open it. You take the lid up off the chassis bottom, and then in my case, I actually undid the bolts that hold the can on the IF thing, and I looked at it, and there's the oxide, and I cleaned the oxide off the bottom of the can with an eraser. I then looked down at the chassis. It didn't look real bad, but it's the similar metals. It's aluminum on steel, and if the oxide's basically on the aluminum, but the oxide acts as an insulator and for RF. So the whole can is acting as an antenna. So as you pick it up, instead of the magnetic field for the coils that are inside staying there from the shield of the can becomes an antenna. It transmits out 455. It's picked up by another can, something else in the radio, and then it goes in a circle, and the whole radio goes in oscillation. Now, I use the tears or the hard work of somebody else. As soon as I read that, what's the big deal? Take the can off, clean the bottom, put it back together, pick it up. It went away. I did the other 2 cans also. All right. See, whenever I have a problem, I don't want to reinvent the wheel. I go looking for somebody else that's done it before me. Why sit there and try to figure out what the hell's going on? And somebody else figured it out. He went through hell probably, and then in the group he was mentioning other people aren't going to believe him. I went and I took the can out. As soon as I took the can out, this one here you can actually see on camera. It's white with oxide, but the one I took out, it was along the bottom rim where it hits the chassis. I could see the oxide, and I know oxide at a certain frequency, it's an insulator. It's that simple. And you only have a certain amount of leakage up into the can and make the can an amplifier or an antenna, and it gets on another one. And I became an expert with the, remember I made if you go look, I made a radio inside an ammo can. And I noticed up and down the band, it's an AM radio, up and down the, no, it's a shortwave radio. And up and down the band, I would hear zzz, 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 zzz. I'd find like little carriers that were going zzz, zzz, zzz. So the first thing I did was I get a radio out and I put real loud the zzz, 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 zzz in one speaker. I then go through the AM broadcast band. I found nothing that matched it. I went on the FM band, strongest signal in the neighborhood. There it was, all the way up and down the dial, all different harmonics of this local FM station. So I sat there and I emailed a couple people. They didn't know. So I started looking at my design. And I had an oscillator in there, a Franklin oscillator. And it's sitting on a bracket. It's not shielded at all. So I laid a piece of metal in there, and it was grounded to keep the oscillator from radiating over to the front end of the radio, because that's the most sensitive part. And they went away. I was like, holy crap. But you'd never think. So when you build stages, when you look at a really well-designed tube radio, most stages have some type of wall or metal wall. Now I can show you real quick. Since we have this radio upside down. All right, you ready? This here, we're in the frame, hope it's focused. This, let me get my finger on it. This can here, around here, or this wall, this keeps this signal from mixing on this wall. So these coils here are inside their own little shield. And don't forget, also the bottom of this radio goes on and shields this. It also, the bottom of these coils are on the chassis on the bottom side, so they're shielded. But that's what you got to learn. Just because you wire a circuit upright, it doesn't mean it's not going to go in oscillation. And that's one of the things when you build from scratch and you don't steal someone else's design and layout. Let's get this back in the frame. Oh, all right, I see what I did wrong. Got to put my stage up here. This camera makes me crazy when I look over at the monitor. So this white stuff is oxide. It's actually an insulation at certain frequencies. All right, that's all you see. You pick this stuff up over time, and how you do it is you actually build stuff. And sometimes when you build something and it doesn't work right, that's the best thing that could ever happen to you. All right, I have that one video when your regenerative radio doesn't work, and you just have to reverse two wires sometimes. Sometimes you plugged in the wrong earphone. It's a low impedance earphone. It has to be high impedance. It has to be like a tube headphone from the past. If it's using it doesn't have an amplifier, it's using strictly the headphone. Now, I told you that happened to me. I was building a CB receiver, one transistor, and with my birthday money, and Cy Berger at Berger Electronics over in Bloomfield, for my birthday, he gave me an earphone for free. But it was 8 ohms, and I really needed a 2,000 ohm for the circuit. I spent days going over that circuit. And then when I moved here, I realized one day I had all the parts. I went and found the magazine article. I built it exactly the same I had built it. And then I put the high impedance, and it worked. It worked 1, 2, 3. It's a regenerative circuit. And I kept saying, if only Cy had read the description of the part, 2,000 ohms, but he wanted to give me a gift for my birthday. And he gave me an earphone, but it wasn't a 2,000 ohm earphone. And in the transistor circuit, that was in series with the transistor. And it had to be a 2,000. It wouldn't let the circuit have the right bias. It wouldn't oscillate. That's that. But there's certain things that people figure it out. You know, like the guy that figured out the oxide on the bottom of the can. Most IF cans are aluminum. They're sitting on steel. That's two dissimilar metals. So if those metals or around any kind of moisture, it creates a battery. And then the oxide is formed. And then after a while, the can is no longer RF-wise grounded to the chassis. You could put an ohm meter on there, and there are special ohm meters that read less than an ohm. They're special. And you might put one that might work. And then the other thing is the dart. The dart that pulls the IF can down, you want to make sure that's working correctly. But once you know the trick that the IF can is RF insulated from the chassis, even though you see it sitting on the chassis, once you know that trick, that's the fix. And somebody was nice enough to share it. And of course, in the group, other people didn't believe him. He was right. He was absolutely right. And because if you isolate the can with oxide from the chassis, the inside coils radiate to the can, and the can becomes an antenna at 455. And in that section, you have other ones that make it goes in oscillation. Let me just put it. That's the trick. And once you really put it in your head that the can has to be really RF grounded, not grounded, RF grounded. So there's two kinds of grounds. See, that people sometimes they run a real thin wire, across the circuit, up the other side. Well, that's my ground wire. When in a regenerative circuit, you can't run wires that long. And they're like, but that's my RF to the other side. No, you can't do that. That ground has to be as short as possible. You laid out the parts wrong. Now you're forced to make a ground that's too long. It's really an antenna. So it's going to be radiating. So you're going to get the regenerative radio to oscillate, but it's the wrong kind of oscillation. It's freewheeling oscillation. It's not oscillating at the frequency you want to receive. So you're like, but it's oscillating. You can hear it oscillating, but that's the wrong kind of oscillation. It's not controlled. It's not at the right frequency. There's so much to learn. And that's why sometimes when you put something together and it doesn't work, that's a blessing. Like I told you, years later, I was going through my parts bin, and there was the trimmer caps for the circuit. It was used two trimmer caps that cross-referenced for me. I had the transistor. What else? I had something else. And it took me a while searching Popular Electronics online, because it was a circuit that was in like the Circuit Circus or something like that. And it said you can make a regenerative circuit with an earphone or headphone, and you could hear CB and 10 meters. And mine wouldn't oscillate because I had the wrong bias, because I had the wrong earphone. And I always find it a blessing that when I have a problem, I go looking on the internet, and there's a genius there. He spent the time doing all kinds of tests to realize that the IF can oxidize. Now I remembered I had this one, and that white stuff is oxide. Some people call it white rust on aluminum, but that is conductive too. It's almost like silver mica. Silver mica disease is you have a piece of mica, which is an insulator, and the plates for the capacitor are painted, deposited. We use deposited on the mica. So on each side of the mica, you have silver deposited on. That makes the plates up of the capacitor. Well, silver, if you ever seen a silver spoon, it turns oxide black. And watch Shango, he actually takes these things apart, cuts them out, puts another capacitor in. Well, anyway, the silver oxidizes. The black stuff is oxide. It's conductive. It drops away, gets down into something, and shorts it out. And in the case of the tubes, it's conductive, the oxide, and you'll see lightning. Yeah, that's why Shango's turning the lights out. He wants you to see that the silver mica disease, the oxide on the silver, and is allowing the soot's allowing the electrons to jump across the mica down at the end, and it's conductive, and he shows you that's what's actually happening. It's actually silver oxide. They call it silver mica disease because there's silver in there, and there's the mica is the insulator. But what's really happening is the silver, it's silver oxide. That's conductive. When you really understand stuff and really get to the nitty gritty. But like I said, when I had the IF can going into oscillation, I knew I was in over my head. And you got to know what you know. You got to a man's dirty Harry. A man's got to know his limitations. So I put IF can goes into oscillation when peaking. Bing, comes right up. And the guy was in a conference and he was telling people, because other people aren't going to believe him because they don't really fix anything. But he came in and he wanted to tell other people, like I'm telling you, and it's just to help out. And you may never see the problem. But for the guy that has the problem, he keeps bringing the radio out and working with it for a couple hours, putting it away. And he may never think about the fact that oxide could insulate the can from the chassis, and now the can acts as an antenna, and the whole thing goes in oscillation. Where another guy stayed with it, maybe the can looked a little dirty, he decided to clean it, or I think I remember it now. He wrapped some bare wire around the can and grounded it, and it went away. And then it led him to the oxide problem. That's what it was. See, I can remember stuff, but all I know is I didn't come up with the idea. Somebody else did. And I even remember now how he said he knew he had a grounding problem of the can, and you're looking down at it, and it's on the chassis. It's spring loaded on the chassis, but it's not RF grounded. It's grounded. I think I explained it as best I can. Other than that, just clean the bottom of the IF can, and be very careful you don't break the darts. You say darts. Wait till you see. In this case, this is a threaded. There's a nut that goes on here, and you tighten it up. And maybe if you get an oscillation, you go underneath with a tool and tighten it up a little tighter. The oscillation might go away, because then you force the can to actually bite into the chassis. But the type that goes into oscillation, it's a can that has these darts on it. When you work enough with radios, you'll understand what a dart is. It goes through a hole. It's got an arrowhead on it. Only instead of 3, it's only 2 heads, and it's got a split down the middle. You put that dart through the hole, and on the other side it opens up. It keeps the can from coming out. And they're the ones that are more prone to oscillation. But I thought about this when someone asked me. I thought of this can, and this can is really white rust, oxidation. See, if when I go to use this can, if I ever do, I'll clean it up with Scotch-Brite. I don't use spray on anything. You know what Scotch-Brite is, right? It's that it's a plastic pad, and it's got an abrasive mixed in it like sandpaper, and it's used for pots and pans and sinks. And I think that's it. All right, that's it.